Hi and welcome back. So in this video, we're going to continue our discussion about reduced row echelon form and discuss how this relates to different types of systems. So we've talked about different types of systems of linear equations. Specifically, we have independent, dependent, and inconsistent systems. So as a reminder, independent systems have one solution, dependent systems have infinitely many solutions, and inconsistent systems have no solutions. And we want to talk about how these types of systems relate to row reduction and reduced row echelon form. Thus far, we've done examples with independent systems and row reduction. So an independent system will have one solution, and everything in row reduction will work out and we'll get to reduced row echelon form as intended. So if basically everything goes off fine, nothing seems wrong, you have an independent system where you're able to come up with one solution. So for the other two types of systems, things will happen while you're trying to row reduce that will indicate to you that you're in one of these other cases. So for dependent, what will happen is that you will typically end up with a row of zeros. So you'll be doing something and a row will entirely cancel out. So you'll end up with a whole row of zeros. And this typically happens because one of the rows is just a multiple of the other one, so you're kind of repeating rows maybe without realizing it, and so one will disappear when you're adding or subtracting them. When this happens, you know that you're in a dependent case when you have a row of zeros, and then we just have to do some work to find a description of the solutions. Then for inconsistent systems, what will happen is you'll have a row where on the left-hand side, everything becomes 0, but on the right-hand side, you're left with a value. So you're ending up with a statement like 0 equals something that isn't 0. So you'll have zeros on one side and something not 0 on the right-hand side of that vertical line. Basically, when you're row reducing, a false statement appears. So you end up with something like 0 equals something not 0. This tells you that there's something wrong with this system and it is inconsistent, so there is no solution. So now I want to go through two examples, one where we end up with a dependent system when we're working through the row reduction, and one with an inconsistent system during row reduction. Okay, so for the first example, let's row reduce and classify the augmented matrix that looks like 1, -3, 4, and 2, -6, 8. So with this matrix, I already have a 1 in the first position, so that is good. So I want to get a 0 in the spot below it. So I want to make this 2 into a 0. In order to do that, I need to subtract 2. So I'm going to do something like the second row minus 2 of the first row. So in that second row, we're going to do 2 minus 2. Then we'll do -6 minus 2 times -3. And we'll do 8 minus 2 times 4. So I'm taking that first row and multiplying it by 2 and subtracting it from the second row. When I do this, in my second row, I'm getting 0, then -6 plus 6, which is also 0, and 8 minus 8, which is 0. So in doing this, I ended up with this row of zeros. Often when this happens to me, I go back and look at the original matrix and just see if one of the rows is more obviously now a multiple of the other one. So here you might notice when you go back to the beginning that row 2 is just a multiple of row 1. We just take row 1 and multiply it by 2, we get row 2. And so that's why they cancel. And this further reinforces that we have a dependent system. So we really only have one equation, it was just disguised to look different in this second row. So just to write out the final answer before we move on, so for the solution, we want to write an x-y pair that goes with this. I'm going to try something a little different. This time I'm going to leave y as the variable, and we're going to solve x in terms of y. So if we look to our equation that's from that first row, we could write it as x minus 3y equals 4. And so here, I'm actually just going to solve for x. I can say that x is equal to 4 plus 3y, and that's what I'm going to write as the x value for my solution. So any point of the form 4 plus 3y and y is going to be a solution to this system. Okay, let's go to the next example. So for this example, we're going to row reduce and classify the augmented matrix that looks like the following. So we have 1, 2, 1, 2, 0, 1, 2, 2, -3, -1, 7, 6. So when we do the row reduction, we're just looking first for what we already have done. I notice that we have a 1 in the first row and we have a 0, 1 in the second row. So we're going to move directly on to the third row and work on getting the 0, 0, 1 for the third row. So first I need a 0 in the first position, third row. So I need that -3 to become 0. To make -3 into 0, I'm going to add 3 to it. So I'm going to take our third row and add 3 of the first row. That first row has the 1, that's the thing I'm going to use to cancel out this -3. So I'm taking the third row, adding 3 of the first row, and that's going to become my new third row. So I'm going to do this without writing out too many steps. We do -3 plus 3, that's 0. We do -1 plus 6. I'm doing 3 times 2 is 6. -1 plus 6 is 5. I'm doing 7 plus 3, that's 10. And I'm doing 6 plus 6, that's 12. So I've taken that first row, multiplied it by 3, and I'm adding it to the third row. So I'm left with 0, 5, 10, 12. Now I have that 0 in the position I want, and I'm going to move on to the 5. So I want that 5 to become a 0 as well. To make that happen, I'm going to subtract 5 from it. I'm going to take off 5 of the second row. This is going to become my new third row. So I do 0 minus 0, 0. I do 5 minus 5, that's 0. And then I'm doing 10 minus 5 times 2. So that's 10 minus 10, which is also 0. Okay. Then lastly, I have 12 minus 5 times 2. So that's 12 minus 10, which is 2. So in doing this, I ended up with this row that looks like 0, 0, 0, 2. This is the same as the statement 0 equals 2, which we know is not true, and so this indicates to us that this is inconsistent. The system has no solutions, it's an inconsistent system. So when you're row reducing, it's not that you did something wrong, it's just that the system is inconsistent or dependent. When you have everything on the left-hand side becoming 0, that just tells you you're in one of these other cases. Alright, so those are some examples of a dependent and inconsistent system using row reduction. Thanks so much for watching, and I will talk to you in the next one.